Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Laoloa and I've been guiding you through the chemistry course. In this particular lesson, we'll be considering chlorine and its compound. Of course, we'll be looking at the halogen family as well. So we'll start with chlorine. We'll look at the properties of chlorine. Then we'll talk about the uses of chlorine. We'll look at the hydrogen chloride gas. Then we'll talk about the hydrochloric acid. We'll talk about the chlorides generally. Then we'll look at the halogen family. We'll pick them one after the other. Then we'll compare the properties of the halogen family. That's the similarities between them. And that will be the end of the lesson. So let's go into it. So what is chlorine? Well, chlorine is one of the very interesting gases that I find quite fascinating. It is used, okay, let me keep that for another time, but let me mention it all the same. It is a very great use. It's used in making many things that we find around us. Yes, many things. Those things we'll discuss when we go to the uses of chlorine. Chlorine it has a greenish yellow coloration. It's a greenish yellow gas and it has a choky smell. Chlorine actually is a group 7 element. In fact, the most important of the group 7 elements, which means that it has some interesting properties. So let's consider the properties of chlorine. Properties of chlorine. Okay, before we go to properties of chlorine, let's talk about the laboratory preparation of chlorine. Chlorine is prepared in the laboratory using these particular experiments. Manganese 4 oxide reacted with hydrochloric acid will produce manganese chloride, that's manganese 2 chloride, water, and the chlorine gas would be evolved. Manganese 2 chloride, water, and chlorine gas will be evolved. So in the industrial way of producing chlorine is through the electrolysis of brine. The electrolysis of brine. So what are the properties of chlorine? Well, we have the physical properties of chlorine. Let's always start from the physical properties. So talking about the physical properties, chlorine is soluble in water. It is very quite soluble in water. About 2.5 cm cube of chlorine will dissolve in 1 ml of water at STP. So that's a reasonable thing to note. Also, fluorine is denser than air. It is about 2.5 times as dense as air. So it is actually heavier than air. If chlorine is in a particular location, it would come down. Chlorine has a greenish yellow color. I said earlier, it has a choky smell. It has a greenish yellow coloration. And yes, chlorine is poisonous. There's a certain volume of chlorine that one is allowed to ingest. Let's take in. Anything above that, it becomes very, very harmful. Let's look at the chemical properties of chlorine. So, what are the chemical properties of chlorine? Chlorine behaves just like every other group 7 elements, and of course, naturally, group 7 elements are very, very attracted to alkali metals. They're very, very attracted to alkali metals, which means they have very, very high electropositivity. They are attracted to metals. So, generally, chlorine reacts with almost all metals. We have to produce salts, direct combinations. That's in form of potassium reacted with chlorine gas to potassium, obviously, and that will give us KCl. We can also have magnesium plus chlorine to give us MgCl2. So it reacts with metals to produce salts. It reacts with hydrogen to produce the hydrogen chloride gas. The hydrogen chloride gas, which when dissolved in water, forms hydrochloric acid. And that also has very many uses. We'll talk about that when we get to the hydrogen chloride gas. Also, the chlorine also reacts with other other non-metals on very special conditions to form several different kind of radicals. It is a bleaching agent. It works as a bleaching agent. When chlorine is reacted with water, it kind of like displaces one hydrogen and it creates a kind of compound, HOCl, and this compound is unstable in the presence of light, and that would have two. Okay, let's just, it's an unbalanced equation. So you have HOCl. This particular compound is not stable in the presence of light. Now, as this particular compound comes to the presence of light, it dissociates, thereby giving off, it can create, this compound can lead to two different things coming up. We can have HCl plus oxygen, that's in case of two particular of its structure. So in the presence of this it bleaches off whatever dirt, and it is a very, very good bleaching agent, a better bleaching agent than most other compounds. Of course, the chlorine gas also, it displaces other halogen family members from other elements. Of course, we have the halogen family member. The only one that cannot be displaced by chlorine is fluorine. All the others, that is iodine, bromine, they can be displaced by chlorine. Chlorine can displace both of them. Of course, it is a very good oxidizing agent. It oxidizes components into, it takes electrons from particular compounds from any reducing agent. The reducing agent is the one that is willing to donate. It is an acceptor of electrons. Those are basically the chemical properties of chlorine. Alright, let's take a short break. Let's see what we have learned so far in this lesson. In a few seconds, some questions will be displayed on your screen. Please do well by answering them, and we'll be back in a few. Thank you. Welcome back. So, we talked about the properties of chlorine. Let's also take out one or two other things about chlorine before we go to talk about the uses of chlorine. So, how do we test for the presence of chlorine in a particular system? Or maybe you have a particular gas and you're wondering, is it chlorine? Is it another gas? How do you know? The first thing is to note is this: it is a greenish yellow gas. It is a greenish yellow gas, so which suggests it has its own color. Yes, all halogen family members have their own color. When we come to the others, we'll also mention them. It is a greenish yellow gas, and it has an irritating smell. It has an irritating smell. Yeah, okay. So further testing, maybe after you have checked, you're still not sure. You want to verify it. When you take damp litmus paper, and you put it in chlorine, it turns the damp blue litmus red to show that it is acidic in nature. It turns damp blue litmus red to show it is acidic in nature. What are the uses of chlorine? Chlorine finds its uses in very many areas of our day-to-day lives. One of the uses of chlorine is that it is a very good oxidizing agent. So we use it in the purification of certain materials. We use it in the production of many materials, industrial materials such as bleach making, even in soap making, in germicide production, herbicides production, very many production. Even in the purification of certain salts, we do find the use of chlorine, because chlorine actually is one of the major components, one of the major constituents of our common salts. Also, it is used in the production of PVC. That's this PVC that we use in our houses. Chlorine is one of the agents that is used. It's used for bleaching clothes, bleaching paper production, and many more other industries as that. One of the major products of the chlorine gas is the hydrochloric acid. The hydrochloric acid. The hydrochloric acid can be prepared. The hydrogen chloride gas. The hydrogen chloride gas. The hydrogen chloride gas can be prepared directly by simply mixing hydrogen with chlorine gas, and you have your hydrogen chloride gas. All of them are gases. So this is how we produce the hydrogen chloride gas industrially. In the laboratory, the hydrochloric acid is produced using this particular expression. This expression that sodium chloride reacted with the tetraoxosulfate 6 acid, and it produced sodium tetraoxosulfate 6 and the hydrogen chloride gas. This is the hydrogen chloride gas. The gas is giving up. The gas escapes from the system. Now, when we talk about the properties, the physical properties of the hydrogen chloride gas, one of the first properties is the fact that it is a colorless gas. It is colorless and it has an irritating smell. It is colorless and it has an irritating smell. It turns damp blue litmus paper red. It turns damp blue litmus paper red. It has a density of about 1.25 as greater than that of air. The density of the hydrogen chloride gas is about 1.25 greater than that of air. It is very, very, very soluble in water. In fact, it mixes with water to produce the hydrochloric acid, and even when it is exposed to air, it forms fumes. It forms fumes. And how does it form the fumes? As it is exposed to air, it quickly attacks the limited amount of oxygen in the water vapor present in that particular air, and it uses that water vapor to create the hydrochloric acid, to show you how very, very reactive it is to water. And also, it does not support burning, neither does it burn. It does not burn, neither does it support burning. Okay, let's take a look at the what's it called? The chemical properties of the hydrogen chloride gas as well as that of the hydrochloric acid. Okay, the hydrogen chloride gas, chemically it reacts with ammonia to give us the ammonium salt. That's in direct relationship, direct combination. It combines with ammonia to give ammonium salt, and it also combines with certain other chemicals to produce certain other metals rather to produce salts. It also reacts with zinc to liberate hydrogen. That's what it does with most of the other metals. Potassium, it will liberate hydrogen, except for those which have a lower reactivity, a lower reactivity than hydrogen in the metal reactivity table. Okay, the hydrochloric acid reacts, of course, with the base, any base, and it will produce salt and water. It also reacts with the trioxocarbonate, whichever trioxocarbonate you're working with. It will liberate carbon dioxide as its end product, and also it is also a precipitating agent for us to be able to identify certain agents, certain elements. Testing of certain elements, we do use hydrochloric acid. It will precipitate out the elements in the particular system. All right. So what are the uses of both hydrogen chloride gas and the hydrochloric acid? What are their uses? We find the use of hydrogen chloride gas in the production, in the synthesis of chloromethanes. Chloromethane. When we talk about chloromethane, it is C, instead of having H, it will be CCl4, where chlorine is actually replacing the hydrogen. So we use the hydrogen chloride gas. The reaction involves the hydrogen chloride gas reacting with methane to liberate hydrogen at each point in time, and at the end of the day we have the chloromethane. Also, the hydrochloric acid is used in the production of gelatin and glucose, which are used in textile industry for in the development of dyes, for ensuring proper production in the textile industry. So we find the use of hydrochloric acid in the textile industry. It is a very good oxidizing agent, so we use it also for oxidation. We also find it very, very important when we want to purify objects and things that need to be electroplated. Peradventure, you want to electroplate a particular steel, you first use hydrochloric acid to clean it. The hydrochloric acid will take away whatever rust that is on the particular metal, and you can go ahead to do the electroplating of the substance. Also, it is used in the preparation and in the testing of several reagents in the laboratory. It is used in the testing and preparation of several reagents in the laboratory. For example, in the production of silver chloride, of course, you need hydrochloric acid. You need hydrochloric acid for many of our reactions in our laboratory, especially in the purification of certain metals. We use the hydrochloric acid. So that is that about hydrochloric acids. So let's talk about chlorides. When we talk about chlorides, we majorly talk about the preparation. There are several methods for preparing chlorides. One of the methods can be reacting the particular element directly with the hydrochloric acid to give you the chloride salt and hydrogen gas to be liberated. In some other elements, you have to take this particular material, that is a particular metal, like in the case of aluminium, you heat it to red hot temperature and then you pass the hydrogen chloride gas over it, and it will form the chloride salt and liberate the hydrogen gas. Also, in some other substances, you just react the acid and the base and you get the substance, get the chloride out. In some other substances, the acid and the oxide state of it, you get your chloride out. In some other cases, we have double decomposition, where one particular element loses a particular substance and become a chloride, and another substance will be formed. And in some cases, we can have direct reaction. You just react directly the metal with the chlorine gas, and you have the chloride of the particular substance. Now, there is one thing to note. Chlorides are not easily decomposed. They cannot be decomposed via heating. They are very, very stable. Chlorides are very, very stable. They do not decompose easily. And they react, all chlorides react with concentrated H2SO4. They react with concentrated H2SO4 to liberate the hydrogen chloride gas. So when you react a particular chloride, maybe iron chloride, you react with H2SO4, it will form iron 2 or iron 2 tetraoxosulfate 6 and the chloride, hydrogen chloride gas. So that is how the reactions of chlorides generally work. So let's look at the halogen family. Since chlorine, we've talked about chlorine, and chlorine is a member of the halogen family. In fact, described as major member, the number one member of halogen family. So let's discuss the remaining family members of the halogen family. We've talked about chlorine, and we have a couple of them. That is, those are fluorine, bromine, and iodine. Of course, we've talked about chlorine. So fluorine, let's start with that. Fluorine it exists naturally in the gaseous form. It is not, in fact, it does not exist freely in nature. It does not exist freely in nature. It's only found in reacted form, either in a kind of substance as hydrogen fluoride or potassium fluoride. It is produced by electrolysis. That's the only way you can produce pure fluorine, by electrolysis in the laboratory, and the electrolysis of potassium fluoride. To produce it, you need potassium fluoride to be your electrolyte. You need a carbon anode and a steel cathode. You need a carbon anode and a steel cathode. It is a yellow gas, a yellow and very poisonous gas. It is highly reactive. In fact, it is the most reactive element that we can talk about, we can think of. It reacts with anything. In fact, it reacts even with some noble gases. It is known naturally that noble gases do not take part in chemical reactions, but only fluorine has the capacity to make certain noble gases take part in the chemical reaction. The only elements which fluorine do not react with are oxygen, helium, neon, and argon. Oxygen, helium, neon, and argon. But every other substance, even xenon, it will react with xenon to produce a compound. It will react with any element. It will displace any element, any electronegative element from any system. For example, even when it is exposed to water, it displaces oxygen So we have something like 4HF plus O2. Oxygen will be given off. It displaces oxygen. It displaces any element from the system because of its high electropositivity. It even displaces chlorine. Now that is the only element that displaces chlorine in the electrochemical series. Okay, let's quickly talk about bromine and iodine. Bromine and iodine happen to also be members of the group 7 family. That's the halogen family, and they also are colored substances. Bromine exists naturally in a liquid form as reddish brown, and iodine exists naturally in the solid-like form as a black solid. So all these elements, they have one outermost electron, which make them very, very reactive, and they do engage in displacement reactions. They displace other substances from their particular compounds. They have many of their salts abundant in nature. Bromine can be created by sourcing the bromine salt from the sea, and that's how it's industrially produced. It is produced industrially by sourcing the bromine salts from the sea and using displacement method and using chlorine to displace the bromine, and the bromine comes out in the liquid form. So that's how we go ahead in the production of this halogen. The halogens are very, very, very reactive. Okay, in a few seconds, a description of a particular chart or table rather that is showing the comparison between the halogens as a family. That is each of them, the relationship between them. It will be on your screen. I believe it's on your screen right now. So if you look at the particular table that we have there, we have chlorine, we have bromine, and we have iodine. We talk about their physical states, we talk about their densities. If you notice, their density is increasing from chlorine to bromine to iodine. Also, their melting points and boiling points also increase. Their solubility also it decreases. And if you look at their electronegativity, we are having a decreasing electronegativity, which suggests that they have an increasing electropositivity. They are oxidizing agents. The best oxidizing agent, of course, is chlorine among them, and of course, chlorine also is a very, very strong bleaching agent, while iodine does not bleach. They all have their allied gases, and the allied gases exist in colorless gases. They all also react with silver and do have different colors. You can take more time to study the chart, the table, and pick up one or two things which I did not mention. Alright, in this particular lesson, we looked at chlorine and its compound as well as the halogen family. And we talked about chlorine, we described it, the group 7 element. It is the most versatile of them all. We talked about the properties of chlorine. Of course, we described it as a greenish yellow gas with an irritating smell. We also talked about the application, the uses. It is used as a bleaching agent, it is used as an oxidizing agent, and the rest of them. We talked about the hydrogen chloride gas and the hydrochloric acid. We mentioned their uses as well. We then went to talk about the chlorides, how they are being produced, before we went ahead to discuss the halogen family. And in the halogen family, we mentioned the fluorine, the bromine, and the iodine alongside with the chlorine, which had been previously well discussed. Then we concluded by comparing the properties of the halogen family. And as we observed from the table, there is a lot of similarities, although some distinctive differences exist between them. Alright, in a short while, some questions will be displayed on your screen. We want to see how much you've understood what was been taught in this particular lesson. Please do well by answering them, and if there is any part of the question, any of the questions which prove to be difficult, you can watch the video one more time. Thank you.